The other day in class, you guys took FRQ number 2 from the 2016 practice test, and this is the what did we do wrong summary about the common mistakes that everyone made as a class. So this is the actual question if you wanted to read through it as a refresher. So the first recurring mistake that I saw was defining the parameters. Okay, now before we get to the parameters, let's talk about the samples. There were 9,250 men in Group A. These were the people that ate the most chocolate, and then 9,250 men in Group B. These were the people that ate the least chocolate. It then gave some numbers as to the number of people in each group that went on to have strokes. So those are the samples. Remember, when we define parameters, they're about populations, and we want to make it clear when we write these that it's talking about all the people. So the way we do it is by saying that PA represents the proportion of Swedish men who would be classified into Group A, okay, not just the people who were classified into Group A. Saying that they were classified into Group A is really referring to the sample, okay, or if you say that they're the people who ate the most chocolate, it's really talking about the sample. So we're talking about all the Swedish men who would be classified into Group A for their proportion or PA, and then PB would be the similar proportion of Swedish men who would be classified in Group B. Second recurring mistake is a number of you used P instead of P hat in the success-fail condition. And this also goes back to samples versus parameters. Successes and failures are based on the samples, so these should be represented by the variable p hat for a sample statistic, not the variable p for a population parameter. The actual rubric avoids this entirely. They don't write like n times pa or n times p hat a as it should be written. They just say this sentence here: there were 458 cases with strokes, 8,792 without strokes in Group A, and 543 cases with strokes and 8,707 without strokes in Group B. All sample counts are larger than 10. Okay, if you feel like you're going to get confused or might make a mistake as to which one you should use, just avoid using them entirely. Lastly, Part B referenced a newspaper article on the fact that it drew a conclusion that eating more chocolate would lead to a lower risk of stroke. This is an incorrect conclusion, and it's because they did not conduct an experiment. This was an observational study. There were no treatments imposed. Okay, and because of that, they can't draw any causal conclusion. To go a bit further, it's possible that a lurking variable was present. For example, maybe younger participants are more likely to eat chocolate. Maybe older participants are less likely. And along with that, with increased age comes an increased risk of stroke. So it's not unreasonable to believe that if that's the case, age could be a lurking variable in this experiment. That being the case, we would want to randomize who eats chocolate, who doesn't, and that would allow us to actually draw that causal conclusion.